On the scheduling handout, example 2. With these scheduling example problems, our decision variables are always going to be the number of workers to put on each shift. So first, I just want to figure out what shifts there are to schedule. This problem is a little bit different from the last one because there are two different kinds of shifts. There's a 12-hour shift and then an 18-hour shift. So my decision variables will be the number of firefighters working the following shifts. Again, two different kinds of shifts, so I'll have two sets of decision variables. One for the 12-hour shifts, and then one set for the 18-hour shift. So this is one of the harder parts about these scheduling problems is thinking about what are the 12-hour shifts. Let's think if someone started at midnight, that worker would work until noon. That would be a 12-hour shift. If they started at 6 a.m., they would work till 6 p.m., and so forth. Those are my 4 possible 12-hour shifts, starting at each of these time periods. Now I'll think about the 18-hour periods. If someone starts their shift at midnight and then they work 18 hours, they'll go until that's 18 hours, or 3 6-hour periods. Continue to go ahead and fill in all the 18-hour shifts. And these are my 4 possible 18-hour shifts, starting at each of these time periods. Make sure you can figure out this on your own, because you'll have to figure out the different shifts on your own for exams and quizzes. I'm just going to sum up the total that are working the 12-hour shifts. And also the total working the 18-hour shifts. So we decide who works these shifts, and we want to make sure they cover these constraints or these time periods. To understand the overlap between the shifts and the periods, we make a time grid. This time grid will show the number of firefighters working the following 6-hour periods, so I'll do that across the top. And who works the shifts along the side. Copy and paste. Copy and paste. The firefighters working midnight to noon cover midnight to 6 a.m. 6 a.m. to noon. Keep going for each shift. This last one, 6 p.m. to 6 a.m. will wrap around. Start at the beginning here. They get off at 6 a.m. Now for the 18-hour shifts. Cover 3 time periods, 3 6-hour time periods. And wraps around to 6 a.m. I want to sum up and find the actual number of firefighters working during each 6-hour period. So sum those columns across each 6-hour time period. That must be greater than or equal to the minimum required, which is found up here. So I'm just going to do equals my data. In the previous example, our objective was to minimize the total number of officers working. This one now is minimizing total cost, so a little bit different. So total cost will be my objective cell. There's 2 components to total cost in this problem. There's a cost for the 12-hour shifts and a cost for the 18-hour shifts because they're paid differently. We'll start with the 12-hour. Everyone working the 12-hour shift is paid $18 an hour. This is per hour, and they work 12 hours, so we'll multiply this by 12. The 18-hour shift gets a little more complicated. Everyone working the 18-hour shift gets paid $18 for the first 12 hours worked. So that's per hour, so I'm going to multiply that by the first 12 hours they work. Then they also get paid, so plus 22 hours for their overtime of 6 hours. My total cost will be a sum of both cost components. Let's solve it. All right, we have a solution with all constraints satisfied. Each time period has the minimum number of firefighters working, and we have a minimum total cost of $45.48.